In this video, we're going to be talking about how to interpret and draw a constant velocity graph. We'll start off over to the left, where a runner starts from the 50-meter mark and runs back to 30 meters in 5 seconds. So if you wanted to plot the position time graph, that one's fairly simple because they gave us some positions to work with. So you're going to directly plot that beginning point and ending point along with that 5-second interval, just like this. Alright, so I finished plotting my position versus time graph. I started at the 50-meter mark at 0 seconds, and at the end of the 5-second interval, I finished at a final position of 30 meters. I want to make sure that my line is a straight negative slope to show that they have a constant rate of motion moving from 50 back to 30. Now for the second part, we have to make sure we calculate the velocity for the velocity versus time graph. We know that we're going a total of 5 seconds as we did for the first graph, but we just have to make sure we calculate the velocity. So we're going to go ahead and use this formula over here. Velocity equals delta x over t, and we know that delta x is a change in position, or the displacement, which is the final position minus the initial position. So I'm going to go ahead and solve for that velocity and then plot the graph. Okay, so I finished my calculation over here. I found out how much it moved. It moved back 20 meters, so its displacement was negative 20 meters within that 5 seconds. Negative 20 meters divided by 5 seconds gives us a velocity of negative 4 meters per second. So all I really had to do is mark the negative 4 underneath the 0 on my graph, and then make a nice straight flat line to show that it's staying at a constant negative 4 meters per second for that 4 seconds. For our next graph, we have a position versus time graph, and they've already directly shown us most of the information we need. We know our starting position is 3. We know our final position is 12. And we know our time is 9 seconds. So typically in a problem like this, you'd be asked to solve for the velocity, which would be finding the slope or using this equation. Both of them are basically the same exact thing. So let's go ahead and solve for that velocity. Okay, so we found a velocity of 1 meter per second. So working out a problem like this is actually fairly similar to working out a word problem like the first problem that we did. The only difference is that you have to pull your values from your graph. So for some people that can be a little bit more difficult, but you go ahead and just use the same sort of process, as in you label the variables that you know based on what you see from the graph, and then you go ahead and find the formula that fits your needs, and then do the little bit of algebra to solve for that problem. For our final one, we have a velocity versus time graph with 2 constant velocities, a constant velocity of 3 meters per second, and then a constant velocity of negative 2 meters per second. So for this last one, we don't need the we don't need the velocity. We're going to go ahead and solve for the delta x for each of these sections. So let's go ahead and label our variables and then solve for the delta x for each of these 2 portions of the graph. Okay, so we found the displacement for both of the sections. For the first section, we've moved 15 meters forward, and then for the second section, we've moved 8 meters back. And then if you wanted a total delta x, we would just go ahead and do 15 meters minus 8 meters for a final delta x of 7 meters. Okay, so depending on what the problem is asking you, we can find the displacement for the first portion, the second portion, or the total. And then if you were looking at just total distance without considering the direction, you would just add the absolute value of both of these, and your total distance would be 23 meters because they've moved a total of 23 meters if you're not considering that they've moved backwards. As we did solve it, we did consider the directions, so we do have some negatives, and then our total displacement would be 7 meters. Okay, so that's how you solve a constant velocity problem as far as sketching a position versus time graph, a velocity versus time graph, and then doing it the other way around, given the graphics, solving for the different values based on the values that you pull from the graph. So thank you for watching and listening.